video, that fourth property will be remaining inverse. A plus minus A equal to 0 and A into 1 upon A equal to 1. 0 is called as the inverse of identity and 1 is called as the identity, multiplication identity. So A plus minus A equal to 0 and A into 1 upon A equal to 1. 1 upon A is the reciprocal of A. Therefore A into 1 upon A equal to, we get 1. That A will be cancelled, we get 1 there. That is the fourth property. Next point, decimal form of any rational number is either terminating. Terminating means division will be completed, so we get remainder 0, or non-terminating recurring type. You have a symbol of recurring 2.725 here, this sign of recurring, and if single number will be repeated, then there is dot on single number. This is called as the non-terminating recurring type. But there are properties identify terminating or non-terminating recurring type. So remember, there are two notes are there. First, if the prime factors of the denominator of a rational number are 2 or 5 only, then decimal expansion is terminating. For example, 5 divided by 4. Prime factors of 4 are 2 into 2, means all 2 are there. So when we 5 divided by 4, we get complete division. So we get that decimal form is terminating. All division will be 15 divided by 25 or 11 divided by 25. 25 factors are 5 into 5. All 2 or all 5 means it contains 2 and 5 also. For example, 10. Factors of 10 are 2 into 5. Prime factor means all factors are 2 and 5. Then this also is terminating. That is the first property. Then the decimal expansion is terminating. So division will be completed. We get remainder 0. That is the first property. And second, if the prime factor are other than 2 or 5 also, then decimal expansion is non-terminating and recurring. Means, for example, 7 upon 36. This type. Here also I take that example 36. 30 factor prime factor 2. 18. You are in a standard. You solve that factor. 2. Then 18. Again 2. 9. Then 3 into 3. These are the factor of 36. It contains 2 times 2 and 2 times 3 means not other factor are 2 or 5. Some factors are 3 also. Then when we divide 7 by 36, we get non-terminating recurring type. So there are 2 examples are given. 101 upon 8. Then we get division will be when we divide and solve that this answer. 12.625. Then we get terminating. And 17 upon 36, 30 factors are 2, 2, 3, 3. Therefore, we get division 0.472222. All division will be 2. So we get sign of recurring there. Dot on 2. When 3 whole numbers are repeated, we take the symbol of line. And when single number will be repeated, there will be dot. So that is non-terminating recurring type. These are the 2 types of that, non-terminating and terminating recurring type. Next type is to express the recurring decimal in P upon Q form. In 2.1, this all these property we can use when we can solve the exercise 2.1. So to express the recurring decimal in the P upon Q form, there is property. Note the number of recurring digits after decimal point in the given rational number. If one digit after point multiply by 10. If 2 digit after decimal recurring decimal means, for example, 2.7. There is 1 decimal. Then when we convert this number into P upon Q form, multiply this number by 10. If 2.72 recurring number, then there are after point 2 digit, so multiply by 100. And then if 3.732 there are decimal, then you multiply by 1000. This is the property. Method will be changed to solve the example. When we take the exercise 2.1, we can solve. Only property is that after decimal, 1 digit will be recurring, multiply by 10, 2 digit will be recurring, multiply by 100, 3 digit will be recurring, then multiply by 1000. This is the property we express the decimal in P upon Q form. Recurring decimal. So not only single decimal, there is recurring sign. Then we convert by using this property. Multiply by 10, 100 and 1000. On this, all this property we can use in the practice set 2.1.